Today we're going to talk about section 9.2 Box and Whisker Plots. So the section starts out with reviewing or mentioning measures of center. You can go back and watch that lesson, but there are three measures of center: mean, median, and mode. And the mean, the way you can remember it is by thinking, you mean I have to calculate the average? So mean means average. Median is, once again, means middle. Mode starts with MO. Most starts with MO, so mode equals most. It's that most often occurring number. Now for list A and list B, there is no mode. There is no number that appears more often than any other number. So these lists don't have modes. The mean, I would add these numbers in list A together, and then I would divide that sum by 6 because there are 6 numbers, and I would get 17. And if I did that for list B, I would get 17 there too. All right, median. I was worried there I wasn't recording. I'm just talking to myself. All right, so median is that number in the middle, and to find it, you have to rank the data least to greatest, and then match up the endpoints, and then the next numbers in, and then 14 and 18, and oh, there's not another number in between. So I have to take those two middle numbers, 14 and 18, and divide them by 2 and get the average. And so the median for list A is 16. I do the same thing for B. 1 and 30 match up, 12 and 24, 15 and 21, and that leaves 16. 16 is my median. Now if I look at these two lists and I'm only looking at the mean and the median, I think, oh my, these lists are very close. They're very much the same, until I look at the actual lists and realize, no, they're not. There's a wide variety. So the range would help me see that, and I would do the greatest number in the list, which is 28 for list A, minus the minimum number, and that gets me 18. And then the range for list B would be 30 minus 1, that gets me 29. But even ranges are somewhat similar, not a little bit. So there is another way to describe numerical data, and it's with using 5-number summaries. The 5-number summaries include the median. So let's go ahead and mark that up into our lists right away. The median for list A we've already calculated, and it was 16, and it's the median. And the median for list B was also 16. Now notice the median for list A does not actually appear in the list of data, whereas the median for list B does actually appear in the list of data. Now if I'm going to rewrite this set of numbers so that I can mark it up and kind of show you the picture of where these 5-number summaries come from. So if I were to divide this into 2 halves, I would have the upper half to the right and the lower half to the left of my median. Now the now I have two rectangles boxed around those lists. If I were to divide each of those rectangles in half, I would have one half there and one half there. So now I have this list divided up into four. So 4 quarters. So these are quartiles. The end of that first quarter is the first quartile, and you would write it as Q1. And then the end of the third quarter is the third quartile, or Q3. So now we can add that into our 5-number summary. This is Q1, and 19 is Q3. Okay, I had to step away to put the dogs out, and I think I left at the third quarter. So we've marked 19 as our third quartile. And then our minimum number is 10. And so we'll mark it as the min. And 28 is the max. It's the greatest number, maximum number. Everything to the left of the median is the lower half. And everything to the right of the median is the upper half. So all of these things are terminologies that you should know. You need to know what the lower half is referring to, the upper half, the quartile, the quartile, first quartile and third quartile, the minimum and the maximum. So now let's mark up list B in the same way. Now notice the difference between list A and list B in reference to the median is that the median actually appears in the list of data for list B, but that is not the way it was for list A. We had to calculate that using the average. So we've got a different scenario here. So I'm going to mark up this list in the same way. I have 1, 12, 15, 16, 21, 24, and 30. Now this is my median. That 16 is my median. It's a number in it. So that, it's like that becomes the wall separating the left from the right. You don't want to include 16 in either the lower half or the upper half. This is the lower half. This is the upper half. 16 doesn't go to the lower half, and it doesn't go to the upper half. So the quarter one, that imaginary line that would divide this, is right there at 12. So 12 is the first quartile, and 24 is the third quartile. So this is Q3, and 12 is Q1. 1 is the min, and 30 is the max. Then you would write it using this format right here. Min hyphen Q1 hyphen median hyphen Q3 hyphen max. So list B's 5-number summary would become 1, 12, 16, 24, 30. And list A's 5-number summary would become 10, 13, 16, 19, 28. And then you know that which number, like it always has to be written in this order. So you know that the 12 is the first quartile. You know the 24 is the third quartile. All right, so box and whisker plots or box plots. It's a way of graphing to visually represent that data of the 5 number summaries that we just were talking about. If I had, I'm going to read from 427. This box and whisker plot represents the 5 number summaries for, oh, I thought it gave like a little story about what it's representing. It doesn't do that. So I'm just going to move on. So it gets its name Box and Whisker Plots because it has this box in the middle, and then that box has whiskers. Isn't that cute? So we can know the min because it's right here. Okay, I was trying to figure out if it was counting by ones or something more, but it's not. It's counting by ones. So the min is 16. The next number in the 5 number summary is the Q1, or the first quartile, and that is 36. That's represented by this line right here. So the next number is 36. The next line you come to, we're looking for the red vertical lines that we come to with the box and whisker plots, or box plot, is this one right here. And it's in the middle of the box, so it's the median, and it is 54. So that's the next number we'd write. And then the next vertical red line we come to is 74. So that's the third quartile. And then 84 is the last one, and that is the maximum. Easy, right? All right, so example 9.2a, this is from Abeka's Pre-algebra, page 427. It wants you to evaluate the box and whisker plot and fill in what each of these values, minimum, Q1, median, Q3, and maximum, are, and then come up with the 5 number summary. So each of these incremental grid lines is a count of 2, and this is right in between 28 and 30. So the minimum is 29. The next vertical line we come to is right there, and it's right in between 58 and 60. So Q1 is 59. The next vertical line is right there in between 78 and 80. So it is 79. The Q3 is right here, and it is 106. And then finally, the maximum number is right there, and it is 122. So then the 5 number summaries are simply taking these 5 numbers that we've just come up with and separating them by hyphens. Just like that. All right, example 9.2b, page 427, instructs you to draw a box and whisker plot using the following 5 number summary: 5, 14, 25, 38, and 47. Well, we know that 5 is the min, 47 is the max, and 25 is the median. Then the number separating the min from the median is the first quartile, or Q1. And the number separating the median from the max is the third quartile, or Q3. So now we just have to mark that. So the min is 5. You start by drawing those 5 lines. Q1 is 14. The median is 25. The Third quartile is 38, and the max is 47. Now we join the quartile 1 and to quartile 3 by boxing in the median. We end up with something like that. It's a little sloppy. And then we need to add whiskers that combine the quartile 3 to the max, and then the min to the quartile 1. And we have our box and whisker plot for our box plot. All right, so this is all well and good, but really what is the point? Well, the box and whisker plots are helpful when you're comparing two sets of data. You can figure things out just by looking at the pictures. So who had the fastest travel time ever here? The fastest travel time ever is represented right there. It's the number that would be the smallest time. So Nathan had the fastest time between the two. But Dean's median time, which is right here, Dean's median time is faster than Nathan's median. Or it's lower than Nathan's median. It's faster. This means that on most days, Dean will get to work faster than Nathan. On most days, Dean gets to work the fastest. And then it also helps you see the range of dispersion. Nathan has a much wider range than does Dean. Dean's only disperses that far. So Nathan has other things that are happening on his way to work that are affecting his drive time so drastically. And so he's probably living in a lot of traffic. Living with traffic, most likely. All right, that's it. Enjoy your homework if that's possible.